This is the answer to Chapter 1, problem number 63 from the Smith Organic Chemistry textbook. And this problem gives us skeletal drawings and asks us to convert them to the lettered drawings. So draw in all the carbons and hydrogens. And so this is sort of a nightmare of a problem. This is going from a less complicated representation to a much more complicated representation, which I'm not sure you would ever want to do, but the problem asks us to do it, and so we shall. So remember, each corner or end of a line in skeletal representation is a carbon atom. And so we just replace all the corners and all the ends of lines with carbon atoms. And remember, hydrogens are not shown in skeletal representation, but we always assume that there are basically as many hydrogens as there can be. So if a carbon is only showing 2 bonds to other carbons, we assume that there are 2 hydrogens on it as well. Yeah. Okay, so just bear with me for a moment, and I will do my best to write this in as quickly as possible. Again, this is probably not something you would ever want to do. It's always best to simplify things as much as possible, and this is sort of going in the opposite direction. It's taking something that's much easier to look at and making something that is quite messy to look at. So that's A. So then for B, we're just going to do the same thing. Take any ends of lines and any like corners or junctions of lines and replace them with carbons. And then assume that each carbon has as many hydrogens on it as possible. So for example, this carbon here has a double bond and a single bond to 2 other carbons. So we'll put 1 hydrogen on it to give it its 4th bond. And that's the pattern that will follow. Yeah, okay, I'm going to stop talking and just draw. There's not really a lot to say about this that I haven't said already. And mostly at this point, it's just drawing things in. Okay, so there's B. C is going to, again, be exactly the same thing. Oof, C's a lot of carbons. And so actually what I'm going to do is I'm going to go through and draw all my carbons in, and then and nitrogens and oxygens and stuff. And then I'm going to go back and fill in my hydrogens, except for like these CH3 groups. I'll just throw the H3 on there. Okay, so after that, it's really just a matter of filling in hydrogens wherever possible to give everything the correct number of bonds. Okay, and D is another large one, so I'm going to give D its own page as well. So D is a steroid molecule. All right. So later in the book, actually quite a bit later, you'll learn about the distinctive shapes of steroid molecules, and you'll be able to recognize them on sight. And part of the distinctive shape that they have is this 4 fused ring structure. Okay, and then an OH here. And then after that, it appears to be just a matter of filling in hydrogens. So again, not to beat a dead horse, so to speak, but I'm not sure why you would ever want to do this. It's taking, it's taking a way of writing a molecule that's quite simple and making it quite a bit harder, and certainly much less pleasant to look at. So I guess perhaps the point of this problem is to show you how great skeletal structures are and why you would want to utilize them whenever possible. So let me just double check very quickly that all of my carbons have the correct number of hydrogens here. So each carbon should have 4 bonds, of course. If you see a carbon here with more or fewer than 4 bonds, and I'm missing it, assume that I made a mistake. But I don't see any as I'm looking at it right now. They appear to all have 4 bonds. And so that's the answer to D. And overall, that's the answer to chapter 1, problem number 63.